So yeah, uh, so we are talking about OOPS, and then as I said, after OOPS, we will talk about advanced concepts. In advanced concepts, I will be talking about iterators, generators, and then decorators. So this is the plan for today. So yeah, that being said, without any delay, let's start. So if if I start on OOPS, OOPS stands for Object-Oriented Programming Language. An object-oriented programming language. If you heard of this term, what comes to your mind? The first thing that comes to our mind is class. Second important thing comes to our mind is object. Third thing would be inheritance,
Polymorphism.
yeah, polymorphism. Anything else? Encapsulation and
Abstraction.
abstraction. So yeah, all these comes into our mind. So before we go all these concepts in deep, I just want to ask whether is Python object-oriented programming or not? This is my first question. Whether it supports classes, objects, polymorphism, inheritance, encapsulation, and abstraction, whether it supports OOP or not. That is my first question. I have to ask this question to myself. Yeah, as already Python has invented in late 1990s. So yeah, there is no doubt. Actually Python is an object-oriented programming language. Is Python procedure-oriented language, POP, or is it functional-oriented language? Yes. So it is both actually. It is a mixture of both object-oriented programming language and procedure-oriented programming language actually. So as Python, as I said, it is an object-oriented programming language. So now let's revisit our terms and let's talk about one by one in detail. So let's talk about class. So what comes to your mind when you heard this term class? So why do we need classes? That's my first question.
That's
Why
the
do we need?
conceptual model where you declare everything is just a skeleton that doesn't take any resources as such, like memory or anything.
Mm-hmm,
Yeah,
mm-hmm.
I
Uh-huh.
would say it's a conceptual model of what we want to do.
Okay, got it, got it. But let me put this question again. So why do we need that? Is my question.
That is where we write our variables, methods, and all the functionalities that we wanted to implement in the code, and then the
Mm-hmm,
variables that are used for those functionalities. We embody everything within that class, and that can be used. Like you can just create it's like it's not a physical model actually. You cannot use that unless you create an object of it.
mm-hmm, mm-hmm. Got it, got it. So whatever you're saying, absolutely correct, Nanda. But so let me put this way actually.
It would be a similar kind of methods or something like that.
Mm-hmm, mm-hmm. That is also correct. But I mean, whatever you guys are saying, let me put this way. So what does a list stores? What does list stores? List stores similar kind of objects, or let's say if I want to store something, I can store that in list. Or let's say if I want to store any information, I can store that in a dictionary also. But the problem with list or dictionary or tuple is we need to follow some rules. But uh, what can class give us is class is such an important part where you can create your new data type actually or new data structure. What I mean by that is, let's say if you want to create some student data type, what you can do is you can use classes and create new type of data for student actually. Or let's say if you want to create car data set, you can create that with the help of classes. As Nandan and then others has rightly mentioned, we can have a, a class can have both variables and methods, and also a class is called as blueprint. So if you have blueprint, what you can do is you can create as many number of objects you want. So it's just like our blueprint of our house. Let's say if you have a blueprint of your house, with that blueprint, you can construct one house in one community, and then you can construct the other house with the same house plan or blueprint. You can construct the same house in other community. So let's say if you have some blueprint, you can create objects, as many objects you want. So, as I said, as everyone has mentioned, class is not a physical entity, it is logical entity. It doesn't has some existence actually. So, a class is logical entity. On the other hand, on the other hand, if I talk about object is here, it is a physical entity actually, which means that it has physical existence. An object is an instance of a class, and if you have one class, you can create as many objects you want. If you want, for the same class, if you want to create 100 objects, you can do that. So, well, let's take a few layman examples. Layman examples include, let's say, uh, you have vehicle. Is vehicle is a class or an object?
Object. It's a class.
Object dash.
Is it class or object? Okay, so let me ask this question and then. So my next question is car an object or class?
Object.
It's a class.
Class.
So how are you classifying that? How are you classifying whether a given thing is class or not? Let me put this way. So my next question is furniture is class or an object? And second one is sofa is class or an object?
Furniture is class. Sofa is object.
Hmm. How are you defining that? So you
Because
can't touch and
class
feel. Yeah, you for a class you can't touch and feel that. So if you take furniture, can you touch the furniture? No. But let's say if you want to touch sofa, you can do that. So as someone rightly mentioned, furniture is a class, and then sofa is an object. Uh, and then uh, and then what about vehicle and car?
vehicle is a class.
And then car is an
Object.
can't we define a car as class?
We can still,
class.
We can,
Yeah,
Yeah, we can
yeah, we
define
can.
car as a class.
Yeah, we can define car as a class, but in a sense, what I can define is I can say a vehicle as
Second,
a. Okay, go ahead.
can you let Nagendra in actually? He's waiting.
Yeah, sure. Thank you. Yeah, so here, let's talk about a vehicle. Let's continue our discussion. So, vehicle is no doubt it is a class because that doesn't have any physical existence. And then, what about car? Car, we can define car as an object, and then we can also define car as class sometimes.
Shekhar, if you don't mind, that's kind of misleading actually. So if
Mm-hmm,
you walk through that code, right, like when you say car,
mm-hmm,
you can say that like it's a type of vehicle that you're instantiating, in which
mm-hmm,
case
mm-hmm.
car becomes an object. But if you just say car, it can be anything, right? It can be any model, color, or type. It can be of any type. So unless you specify the model, like say, like you wrote in the code, Audi or BMW, it doesn't become an object. It still becomes a class,
Yeah.
right?
Yeah, got it. And yeah, I'll explain that with an example here. I had that in
Sure.
my yeah, in my notebook. I'll explain that. So yeah, guys, mm, let's continue our discussion on this. What exactly a class is, and then what exactly an object is. So yeah. So as I rightly mentioned, a class is we can create a new type. I mean, we can create a new data type with the help of class, and then a class contains variables and methods actually. So as I said, if a class contains variables and methods, what kind of variables can we store in classes? What kind of variables I can store in classes?
You can take anything,
Local
any two
variables,
types or any other.
global variables.
Hmm. So all these variables are arguments.
Attributes.
Yeah, all these are attributes. They're just like properties, right? So how many types of variables that we can store in classes? We can store instance variables. We can store static variables. And then we can also store local variables. And then if I talk about methods, there are three types of methods actually. So one is instance method, one is static method, third one is class method. So let's talk about all this stuff. Before I go into all this business, I want to ask one question. What is the difference between function and class? Sorry, function and method. And I mean, till yesterday, I was using this word, a function, and today I'm talking about method. And then in yesterday's class also, I'm sometimes using method and I'm sometimes using function. What is the core fundamental difference between a function and a method? So a function,
Actually, they both are blocks of code, but the method is typically associated with an object actually.
yeah, that is one fundamental point. Any other stuff?
Function, it actually represents a specific task, whereas method, it may return some value or something.
Mm, no, I mean in method also we will do some task, and then function also we can return something. Whereas method we can also return something from method. I mean, let's say if you take length function here in length function returns something, right? Length function returns length of the object that we are passing.
Mhm.
Methods are associated with class.
That is one point, yeah. Functions aren't aware. Yeah, we functions, most of them were not associated with classes. Yeah. So yeah, the fundamental difference is if I write any function, uh, how can I call this function? I can call this function directly like this. And then let's say if I define a method, as most of the methods are associated with the classes, how can I call this method? Let's say if I have one method which is fun, how can I call that? I can uh, I can call that method by after creating an object for this class. So let's say I have created an object which is C underscore object is. So I have created an object for my class, and then only I can access that method. So if you see a function you can call directly a function without any instantiation or something like that. But if you see a method, as this is associated with class, uh, you need to create object for that class, and then you need to call that using object reference actually. So that is the fundamental difference.
Shekhar, sorry, but one quick question here.
Hmm. Hmm.
Let's
Go ahead.
suppose if you have some function, a combination of functions and methods in a class,
Hmm.
and within the same class, if you have to call a method, uh, at least in Java, we don't need an object if you're calling in the same class, right?
Okay.
Is it the
Hmm.
same case with Python? In which case, like, what will be the difference between a function and method?
Most of the things, I mean, whatever we written in a class here, I mean, there are three types of methods, as I said. Most probably, we will write that three methods. Here in class, we don't generally write any sort of functions as such. But let's say if I am defining any class, I mean any function in a class, it has to be either of the three methods that I'm gonna discuss. We won't be, I mean, writing specifically. We won't be writing any functions as such in classes actually. Most of the things that whatever we are writing in classes, they are methods actually, and then all the methods whatever we are writing in the class, I would be calling that by an object reference.
So functions can be written outside the class, is that right?
Yes, we can write outside the classes, and then you
Okay.
can directly call them without an object reference.
Yeah, got it. Thank you.
Yeah, so let's continue our discussion on types of. So, as I said, we have three types of variables: instance variables, static variables, and local variables. And then methods, we have instance methods, static methods, and then class methods. So, let's say I have a class method here. So, let's assume that let me take car as a class, and then I have some set of properties. I have here properties or attributes can be a color of the car, model of the car, number of vehicles to the car, or something like that. And then I have a few methods as well. First method that I'm writing here is speed method, and then let me pass self. Let me explain this method in the next coming time, but for the time being, let's assume that we have one method. So this car, for the car, we are having uh, attributes slash uh, variables. These are attributes, and then these are methods. So how can I? So this is a class. So as I said, so if this is a car, how can I call speed? So as speed is a method to that class, how can I call that? I can call that by creating object actually. So here, let's assume that C underscore object. mm, this is how I create an object, and then I can call this method with object, actually object reference. So C dot speed of. So this is how I create an object for class, and then so what's happening whenever we are creating an object is a memory will be created for my class, and then uh, an object reference, whatever the object reference that we are having, we are giving that reference to this object, and then we can store all the variables. See, whatever the variables that are there here, let's assume that all these variables are instance variables. If they are instance variables, I'll talk about that in a time. But all the instance variables or static variables are stored in this object actually. So whenever you create an uh, whenever you create an object, and then whenever you call this, the three things will happen. One thing, a constructor will be invoked. Let's say if I'll talk about all this stuff, but for time being, listen to all this terminology. So a constructor will be called actually. So here, I mean, what is the main purpose of constructor is a constructor is a special method which is used to initialize instance variables, and then a constructor, as I said, it is automatically executed whenever I'm creating an object actually. At the time of object creation, my constructor is called actually. So yeah, uh, I mean, if I create an object, my memory, whatever the memory that my object needs, that memory will be created, and then object reference will be assigned to this object, and then constructor will be invoked. So these are the three things that are happening whenever you create an object for a class actually. And then I'm talking about a self keyword right now. So what exactly self keyword is? A self keyword always points to a current object. I mean, this self keyword, let's say if you have Java background, I think this is this keyword. What this refers is, this always refers to current object. Similarly, in Python, we have something called self keyword. What is the purpose of self keyword is it refers to current object. What do I mean by that is, let's say I have created a car class, and then I have created two objects. Let's assume one is BMW, and then second one is Audi. So these two are the car objects. So, and then I have some set of properties, and then some methods associated with BMW, and then actually, I mean, you'll have some set of properties from RD, and then you'll have some methods that are associated with RD. So With respect to this BMW, as I said, we will have different parameters, and then odd is also having some parameters. Let's say mm, what uh, a self does is that self will always point to the current object. Let's say if I'm working on a BMW object, self will point to BMW. If let's say so I mean the main purpose of self keyword is it points to current object. That's the main thing. And then, I mean, if I'm working with RD card, if I'm working with RD object, so then my self keyword will point to RD object. Yeah, here we had a discussion on what exactly class is, what class contains. Class contains attributes, and class contains methods. And then variables, as I said, we have three types of variables, and methods, we have three types of methods. So all these are the whatever, as I said, whatever we are having, the variables and methods are part of class, and then I am creating an object for my class actually. I'm doing that, uh, we have one more method. I mean, there is one special method in class which is called constructor. So let's talk about that constructor now. So what is constructor? So a constructor, it is a special method in Python which is represented with underscore underscore init underscore underscore. So this is how we declare a constructor in other programming languages like C++ or Java. How we generally define constructors is by using class name. Let's say if I have a car class, how can I define a constructor in Java is, I think we will use car. I mean, the class name is same as the constructor name, right? In other programming languages, but in Python, what we generally do is we use underscore underscore init underscore underscore as the constructor, uh, and then I mean whatever the initialization that you want, you can do that in underscore underscore init underscore underscore. As I rightly mentioned, constructor's purpose is to initialize the instance variables. It is mainly used for initializing the instance variables. And then whenever we are talking about object creation, the third point that I have mentioned is a constructor will be executed automatically at the time of object creation. So yeah, uh, now let's talk about this, and then I'll show you some examples. So let's talk about some variables concept here. The first one is A is instance variable. Let's talk about instance variables. So
Shekhar,
instance.
sorry, but one more question here.
Uh-huh.
Um, in Java, like you can overload different constructors. Actually, you can write multiple constructors in different with the different parameters, or we use multiple constructors in Java. Is it the
Mhm.
same case with Python as well?
No, we can't do constructor overloading or we can't do method overloading. If you want to do constructor overloading or method overloading, what you need to do is you need to use something called a variable length argument thing. I mean, in yesterday's class, we had a discussion on variable length parameters, right? Variable length positional parameters. So you have to use that concept, and then you can implement that using that. But yeah, I mean, that is part of our today's class actually. I will give you more details whenever I go there. But constructor overloading, method overloading is not possible in Python. If you want to do that, you have I mean, that can be implemented in slight other way actually compared to other programming languages.
Okay.
So you can't write like this. I mean, underscore init underscore underscore of one parameter. Here I'm not having any parameters, and then I'm writing something here. Just you don't know why. Okay, see, you can't write like this underscore underscore init underscore underscore of
With a different set of parameters.
with this a different set of parameters. If you write like that, what happens is the compiler will only consider second
The
uh,
most recent.
the most recent one, and then it will ignores the first one actually. And then if you try to call the first one, it will say it will give us error actually. It says we need let's say if it is having one or two parameters, it is saying that parameters missing. Okay.
Okay.
Okay. Yeah. So let's talk about variables now. So first one is instance variables. So for each object, a separate copy of instance variables will be created actually. So for each object, a separate copy of instance variables are created. So let's say so I have let's say I have a car class, and then so in this car class, I'm having a color, number of wheels. I mean, I'm just writing some attributes. What are attributes for car? Color, wheels, speed, maximum speed, that whether it is, what type of car it is, a brand. So all these are attributes, and then let's say assume that it also had some methods like drive. All these are methods. So if let's assume that all these variables are instance variables. So if they are instance variable, uh, how what happens if I create an object? So let's say I'll create object for a class, uh, saying that my color my color is red, number of wheels are four, maximum speed is one something 300 uh, miles per hour, and then brand would be, let's assume, BMW. So if this is my car object, and let's say this as BMW underscore object. So this is my one object, and then I want to create other object for Tesla. Blue, number of wheels four, and then let's say 250, and then let's say it as Tesla underscore object. So let's say these are two objects. As I rightly mentioned, all these are instance variables. So if you create instance variables, let's say here I'm creating two objects. One object is BMW object, and second one is a Tesla object. So for each object, if you are having instance variable, a separate copy will be created. So in BMW object, you'll have color, you'll have a color parameter, a color attribute, speed attribute, and then number of wheels attribute, and then you have a brand attribute. Similarly, for new object, you'll have all the parameters. So speed, color, wheels, and then brand. So object. So if I create n number of objects, if there are instant variables in my if there are instance variables in my class, what happens is for each class, for each object, a separate copy of all the instance variables are created. Okay. I mean, how can we differentiate that? I mean, how can I differentiate instance variables from static variables? Is I need to use a self keyword. So, I mean, if I want to declare instance variables inside a class, how can I do that is using a self keyword. And then if I want to access instance variables of the current class, how can I do that is uh, I can I can access the instance variables of the current object using a self keyword within a class. Outside a class, I can do that. I can access that with object reference actually. So what do I mean by that is, so let's assume that I have a car class and then I have a constructor here. So the first parameter to constructor is always self. I'm not passing any arguments as such to class, but here I'm just statically defining self dot mm, uh, car underscore brand, which is equal to BMW self dot. I'm having second parameter, which is number of wheels, which is equal to 4 self dot color, which is equal to red. Yeah, and then I have one method which is drive, and then this is an instance method. So if I want to say a method as instance method, my first parameter need to be self parameter actually. So let's talk about that whenever we are talking about methods. But for now, our focus is on variables actually. So what are all these color, brand, wheels variables? All these variables are called as instance variables. They are called as instance variables. One because they are accessed with the help of self. So and then if it is static variable, I'll declare that. I mean, I'll talk about that later. But let's say if I want to assign any um, I mean, if I want to create any instance variables, I have to do that by using self keyword. And then let's say if I want to access that car underscore brand inside the class, I mean, inside the method, how can I do that is I can access that with self keyword actually. So self dot car underscore brand will give me the current objects uh, brand car underscore brand, and then current object's wheel value, current object's color attribute value. So if I create an object which is BMW underscore object, which is equal to a car. Okay, here I'll mention it as car, and then I'll have values. So I mean, I'll just call without any values because I'm not passing any values to my constructor. And then BMW, I'll call that drive method. So here, what is self is holding? Self is holding BMW object because I'm calling with BMW object. Always self points to a current object, and then here I'm calling a self dot car off. So self dot. I mean, as I said, this is BMW object, and then for this BMW object, I have all the values. So here, what I mean is, so if within the class, I mean inside the class, I have method. So if I want to access, an instance variable within the class, how can I access that? I have to access with self keyword. If I want to access an instance variable outside the class, how can I access that is with the help of object reference. So now I want to access, let's say, a car underscore brand. How can I access that outside of the class? This is if you access inside of the class, let's say in any of the method, I need to use self. Outside of the class, I need to use object reference. That's a brief introduction about instance variables. What exactly an instance variables is. For each object, a separate copy of instance variables are created. And then let's say if you want to access the instance variables inside the class, you can access that with self keyword. If you want to access outside of the class, you need object reference. That's a short introduction of an instance variables is. Now let's talk about static variables. I have a requirement. What's that requirement is I want, let's say you have two objects, one with a BMW object, and second one, what I have is I have a Tesla object. Here, what I want to create is I want to, for all the objects that are present, I want one or two variables which are common. So let's say wheels is one common variable which is common for all the objects. I mean, which is common for all the classes, whether it can be BMW, whether it can be Tesla, or whether it can be other car. There are some common variables which are common for all the objects actually. So what we do is, if there are some variables which are in common, we can declare that as static variables. For all the for total class, only one copy of a static variable is created actually. So let's say if you create 10 objects, it doesn't matter. All the 10 objects will share the same value. So I mean, if you want to for BMW object, the wheel value is 4. For Tesla object, wheel value is 4, and so on actually. So how can we access that variable? Let's say, let me define a class. So I'll define a class here. Class name is car, and then I'll declare a wheel. So wheel is my uh, parameter. I'll declare that value to be 4, and this is called a static variable. And I will also declare few instance variables. So here, self dot brand is equal to BMW. So see here I'm doing a manual stuff. I'm just assigning all the values manually. But if you want to do that, whenever you are creating an object, you have to pass that, and then you need to capture that here actually. So that is how we generally do. But due to time constraint, I'm hard coding that. So what happens if you create 10 number of objects like this? All the brand names would be BMW. All the values, let's say if I create any number of objects with this code, all the values are same actually. Yeah, so I'll have not wheels, I'll have color as red, and then speed, let's say self dot speed. The maximum speed that a car can attain is, let's say, 250 miles per hour. So yeah, what happens is, let's say if I create two objects here, my wheel is a variable, wheel is a static variable. For entire class, only one copy will be created, and then it is shared among the objects. Let's say if this is BMW object, let's say if it is Tesla object, this will have some set of instance variables, but the wheel parameter will be shared across the variables, across the objects. And third one is local variables. Yeah, how can we access that? Before we go
Shekhar,
there, mhm,
one question.
mhm.
For the static, you don't have to put static in word in front of
Yeah,
it, or
yeah,
it is
you
by
don't need
default
to,
assumed.
yeah, by default,
Okay.
you don't need to put that. And how can we access within the class, and then how can you access the static variables outside of the class? Inside the class, you can use class name or CLS parameter. Outside of the class, you can use object reference or you can use class name. So these are the ways we can access. So inside the class and outside the class. So inside the class, let's say I have a method. How can I access that value? Is by using class name. What is the class name? So class name is car. So car dot wheels. That is how I can access in any method. So let's say if I have def of uh, def of drive method, in that drive method, how can I access my static variable is I can access that with class name, and then outside of the class with object reference. Actually outside of the class is, let's say I create a car object, I mean as BMW object, and then I can access that with either BMW object or class object actually. So this is how we can access the static variables. And then let's talk about local variables. Local variables are local inside a method. Let's say I have a class car, and then I have a def drive method. Here, what I am doing is I'm creating one variable, which is, let's say, speed. This is local variable, which is local to this method. And let's say if I want to access that in other method, let's say service method, uh, if I want to access that speed in service method, I'll get error because this is only defined inside this method. And then scope of the local variable is within the method actually. It's not outside of the method. So yeah, as I said, we have three type of variables. One is instance variables. Instance variables are the variables. For each object, a separate copy of instance variables will be created. We can access the instance variables inside of the class with self keyword, outside of the class with object reference. And then let's talk about static variables. Static variables are the variables where for entire class, irrespective of number of objects, only one copy will be created, and then that copy will be shared among all the objects. And how can you access the static variables inside the class? You can access with the help of class name or CLS parameter. I'll talk about the CLS parameter whenever I'm talking about class methods. And then I can also, as I said, I can also access the static methods outside of the class with object reference or class name. And then let's talk about local variables. So local variables are the variables which are declared inside the class, and then the scope of local variable is within the method. Let's say if I want to access that method outside the method, uh, we don't have existence of that local method. You don't have an access to other methods actually. That is, the scope is within the method or within that premises. Let's talk about three types of methods now. One is instance
Shekhar,
methods. Mhm.
uh, Are you going to show the static variables how to access
Yeah,
actual
sure, sure,
writing?
sure, sure. Yeah. Before we go to methods, let me show that. So yeah, so here, let's see what exactly happening. So here I'm taking car as a class, and then I'm creating an object. One is Audi, and the second one is BMW, and then I'm checking what is the type of Audi. Audi is type of. See here, we are just creating a car data type, and then see here, I'm having a car class, and then I'm having a constructor. Constructor, I'm passing brand and then model. See, I'm assigning self dot brand is equal to brand. What does it mean? Here, what I'm doing is I whatever I'm getting, I am I'm creating values for that object actually. So here, car one is my object, first object. Car two is my second object. For car one, what are instance variables? For car one, for car one object, I have two instance variables. One is brand, second one is model, and then I'm assigning Toyota to one object, and then Honda to other object. So here I'm creating two objects with the instance variables actually. So here, this is an example of instance variables where for each object, for car one, let's say if I print car one dot brand, I'll get Toyota. If I print car two dot brand, I'll get I'll get it as Honda. Honda. Okay. Yeah. See here, I am accessing a brand. See here, car one is my object, and then I am accessing a brand value. So how can I access outside of the class? So here I'm accessing outside of the class. That is the reason why I'm using object reference. Let's say if I want to use inside of the class, how can I use that is, let's say I want to use one more method, which is that, and I want to print a brand is something. So here I'm using the what I'm using the current object's values, current object brand, and then current object model. So here I can access that instance variables with the self keyword. So if I want to access instance variables within the class, I can access that with self keyword. Outside of the class, outside of the class with object reference. Similarly, static method, here I'm declaring static method, static variable. So this variable can be shared to all the instances. So whatever the instance is, see here, I am outside of, as it is outside of the class, I am calling with object reference, or I can also access with the class name. Inside of the class, I'll show that whenever I'm talking about class methods actually. And then this is a model method. So in this model method, this is only the local variable, which is only inside of this method. There is something called private, which is a totally different thing. Private, we will have an access to entire class actually. Within the class, you can access private variable, but the local variables are variables which can only have scope within that method, within that premises of that method. If you want to access uh, outside of the uh, outside of the method, you can't do that.
Shekhar,
Yeah.
one quick question.
Okay, go ahead.
So, any variable that is declared outside the constructor or the method, but inside the class, is it
Or
by default a
instance
static method?
are which are declared outside of the. Can you
Okay.
repeat that?
Let's say I have a variable that is declared inside the class, but it's not
Mm-hmm.
part of any constructor or method. So is it by default a static
By
method
default, yeah,
variable?
by default a
Okay. Okay.
static variable.
So is there a way I can declare any non-static variables inside the class, but that's not part of constructor or method?
I mean, how do you want, I mean,
Let's say I
what
want
is
to
the type
do.
of that? What is the type of that?
It
Oh,
can be a string, integer. It can be any primitive type, or maybe a variable of any other
no,
class, instance of
okay.
any other class.
So what is, I mean, it need to be part of? It need to be part of either of the objects, right? I mean, you want to store that in all the instances, or you want to store that in only specific instance? That is what I'm asking.
So I didn't get your question. Sorry.
My question is, let's say if you declare a variable, which is not static, okay? Uh, let's say that variable name is wheel or something like that. You is that that need to be part of one instance or all the instances that variable?
It has to be part of all. I mean, if it is a class level variable, it can be accessed by all the instances.
So then, what is a point? I mean, my question is, we can declare that as an instance variable, right? That is what my point. I mean, yeah. So, to answer your question, in specific, we whatever the variables which are declared within the class, other than instance, are said to be static. And then, let's say if you declare that as instance variable, you can have that in the, I mean, that entire that variable in an instance. That is an instance variable. Hope that answered the question, or you want
Can
to?
you please repeat that?
Okay, so what I'm saying is, uh, let's say you have a static variable. The static variable can be accessed with that can be shared among all the objects, all the instances. And then, let's say if I have instance variable, so all the whatever the instance variable that I have, uh, that can be accessed within that. I mean, within that instance. So let's say if I want
In
to,
essence, like what I understand is
mm,
anything that has to be common across all the objects are by default, they must be static.
they must be static. Yeah,
Okay.
I have to declare that variable as static.
Shaker, how can I declare instance variables at class level?
Mm, Instance variables. So you want an instance variable to be static type. That is what
No,
you mean to say?
no, static type. Now you added wheels is the static. Okay. If I want to add non-static variable at class level,
Mm,
right now you
You
create
talking about
that,
private?
right? That is you
yeah.
added in the constructor level you initialized.
Mm-hmm. Mm-hmm.
Can I declare self.brand at class level?
I think it is possible. Just let's try that. Self dot wheels, which is equal to 4. It is saying that we can't do that. Uh, I mean, let me check that once, and then I got your question. I haven't tried that, but let me check that and I'll get back to you once. Okay?
Sure, sure. Thank you.
Hmm.
Shekhar, how do
Go
you
ahead.
do the private variables?
Yeah, I will talk that whenever I'm talking about encapsulation. I have that in today's agenda.
Thanks.
So yeah, these are different type of variables. One is class level variables. One instance variables. Second one is static variables, and third one is local variables. Now let's talk about different methods. One is instance methods. Instance methods are the methods. See here, which is used for, I mean, all the self, whatever if you are declaring instance methods, the first parameter need to be self parameter actually. Self variable is the first parameter in the inside, in the instance method, and then whatever the operation that you want to perform with respect to instance variables, you can do that in instance methods. And see here, display underscore info is my method, and then here I'm passing a self keyword as my first parameter so that it has an access to all the uh, current object current object values, current object attributes. That is the reason why here I will be able to access self.brand, self.model, because we are passing self current object reference to these methods, actually the instance methods. So that is what an instance method is. And then we have something called a class method. So what are class methods? Class method, if I want to declare a class method, the class method can be uh, can be created with decorator. Uh, that is at the rate class method is decorator here. So we will talk about the decorators in today's class. We have that, but here set wheels is a class method. So class method, I have to pass CLS as my class variable, and then I can pass any number of parameters. To declare a class method, we need the first parameter is CLS parameter, and then declare uh, I need to declare uh, at the rate decorator as my at the rate decorator uh, as my as a decorator to my method, actually. This is how I mean, we generally write in Python world about class methods. Here, you can change or you can modify class level variables. So let's say if you have any static variables, if you want to modify that static variables, how can we do that? Is you can modify that in class methods, and then we have something called static methods. So static methods are also called as utility methods. Class methods, static methods are, are created with at the rate static decorator, and then you can write all the utility methods under the static method. So as I said, we have three methods. One is instance method, second one is class method, and third one is the static method. Let's see when to use what, which method to use when. Let's say whenever you are working with instance specific data, you need to use instance methods, and then as all the instance methods, the first parameter is self parameter, where you'll have an access to object. You can use instance methods whenever you are working with class level data, class wide data, which means that if you are working with static variables, all the class level variables, you can use static methods, class methods. And then let's say if you the first parameter to class method is CLS, where it has access to all the common shared values. And then we have static methods, which it's just a function inside a class where you can write. It doesn't depends on either of the instances or instance variables or class variables. It is just like a utility functions where you can write some functions level stuff, actually. You can you can uh, you can write whatever the stuff you want. See here, I'm creating one to illustrate all the examples. See here, what I'm doing is I'm creating a bank account class. In this bank account class, I have interest. This is class level variable slash static variable, in which all the objects will share this interest value. And then I have a constructor with owner and then balance. I'm declaring the default value for balance is 0. So yeah, self.owner is owner, and then balance is balance. And then I'm having an instance method where uh, here it works with instance variables. So what I'm doing is I'm just let's say if someone enters some money, I'm adding that to balance. and then I'm displaying the balance amount. If someone withdraws the money amount, I need to check whether there is any insufficient funds in my account. I'll check whether whatever the amount that he is entering is greater than current balance. If it is greater than current balance, I'll simply say insufficient funds. If not, I'll detect the amount and then I'll show what the amount is withdrawn and then what is the current balance. Get balance is also an instance method, as because as it is holding the self, we can return the balance value. And then let's say if you want to change the interest rate, let's say if there is more money or let's say if there is some change in the interest rate, I can use class method and then I can change the class level variable uh, with the class methods, and then I can also create an utility function where it is just a function actually. You can write some stuff. So here what I did is I said just welcome to SoftBank, your trusted financial partner. So here what I'm doing is for bank account I'm passing Krish and then I'm passing 5,000. So if I say as mm, as withdraw, deposit or instance methods, they'll perform the task, and then this is class method. I can access class methods with either class name or object reference. So here I'm calling with class name, and then all the static methods I'll call that by uh, static. All the static methods are accessed with the class name, similar to the class methods. So instance methods, we can access them with the object reference, and then class methods and static methods, we can access them with the class name. That's, I mean, an introduction of
Shekhar, I have
variables,
one
types
question.
of variables. Yeah, just give me a moment. Let me complete this and then I'll take your question, Loki. This is an introduction of class, types of variables, and types of methods. Now, go ahead, Loki.
Yeah, so once you override the instance variable with the new interest rate, is it going to apply uh, the the whatever like we have done before, like deposit withdrawal, right? So does it going to calculate on the new interest rates whenever like a print that balance?
Yes. Let's say if I change the interest rate, from now, whatever operation that I perform, there will be change that happens afterwards. I mean, hope that
Gotcha. Yeah,
answers your question.
yeah, got it.
I have a question. What is
Go
the
ahead.
difference between class and the static functions? So when to use when between the two?
Class methods and static methods. Yeah.
Yeah.
So as I said, so let's say if you are planning to change static methods, static variables are class level variables, then you'll go with class methods where see here every class method will have first parameter as CLS parameter, where in the CLS parameter you'll have all the information related to class level variables. So if you want to change any stuff related to class level variables, you'll use class method. When you use static method, is a static method is just like a function, a simple function, or an utility function. What we generally do is it is irrespective of instance variables, or if you don't want to work on class level variables, you want to write some functionality. What you do is you generally use static methods. So if you are dealing with class level variables, static variables, you'll use class methods. If you want to write separate, I mean, if you want to write separate block, which is not related to either class instance, I mean, class level variables or instance variables, you'll use static methods. Yeah, and with
Basically,
that being,
both serve the same purpose, correct? So there's no difference between the two. That's what I'm getting it based on what you're explaining.
no, I mean,
In
Just
static methods, the class or instance variables will not be available, right?
yeah, uh we can't change the class level variables in static methods.
Okay, got it. Thank you. That explains well. Thank you.
Another
Uh,
question I have, sir. Actually, what is
Go
the
ahead.
file type? What is the difference between .py and .ipynb?
Yeah, I mean, let's say if you want to write a block of code, you can write that in .py file actually. Let's say if you want this bank accounts entire as a, I mean, as a block of code, what you can do is you can write it in .py files. Generally, let's say if I'm developing any big applications, I will use .py files, and then I'll use class level stuff, and then I'll use modular programming. I can do all this stuff with py files. This just IPYNB file is used for, I mean, small purpose applications, and then it is just an where you can write all the inline codes, and then you can run it, and then you can check the outputs. It is used for running small codes, and then chunk of codes, and then checking the outputs. But in real world, what we generally do is we will write .py files.
Okay, thank you.
Now let's talk about inheritance. Generally, there are two types of relationships in object-oriented programming. One is has a relationship, and second one is a relationship. Is a relationship is called as inheritance. Has a relationship. Let's talk about both of them. So, do you guys want 10 minutes break, or let's continue until?
Yeah, we'll take like quick 5 minutes break and then.
Yeah, we will take 5 minutes break. Then we'll take 5 minutes break, and then we'll exactly start after 5 minutes. Okay.
Yeah, sure.
Thank you.
Thank you.
Hey guys, let's wait for 1 minute, and then we can start our session.
Hey, Shekhar, can I ask something?
Hmm.
In instance methods, only instance variables are available.
Yeah, because as we are passing self, the current
Hello.
object. Hello.
Sorry, I think my internet something happened. I couldn't hear. Can you repeat?
So yeah, as I said, as the
Hello.
first parameter, is everyone is listening? I mean, are you able to hear me, guys?
Yeah, we can hear you.
Okay,
Yes.
okay, okay. Let's wait for Smita to join so that I can answer that question again. But right now, what
Okay.
uh, my plan is to complete these concepts actually, at least OOPS concept. Let's speed up some time, because I can't justify entire OOPS in 2 hours. Actually, this is a very vast topic. Whatever is needed, I'll go through all those things actually, and then I have a handwritten notes of mine on this OOPS concept. I'll upload that. I mean, that is in very detail actually. So which is around 20 pages. If you want to refer to that, you can refer to that actually. And then I'll also share a uh, few resources for this OOPS. If you are having great interest, you can refer to that as well.
Sir, up to what level we need to learn this Python? Actually,
Uh,
so do we need to learn as a developer or?
yeah, because we need to know all this stuff actually. Because tomorrow, what I'll do is uh, I'll I'll introduce LangChain. In that LangChain, we have few modules and then we have few classes actually. In module, there are classes and then methods, right? So you need to at least know what class we are using, how to create an objects for that class, all this stuff actually. Uh, yeah, whatever the class, whatever I'm saying, that is more than enough. But you need to have understanding of all this stuff actually.
Okay.
So with that being said, let's start our session. So yeah, there are two types of relationships. One is has a relationship, and second one is a relationship. So has a what exactly has a is so I mean car has engine. Car is one class, and then engine is other class. So I mean, if for every car we have an engine, right? So it is part of that. So if I take a bigger part, there will be a smaller part inside that part. So and this is also this is also a class. So what has a relationship does is that it has totality, and then we have inside, we had that insideness as well. We will see an example so that you'll get more understanding. And then is a relationship is just like an inheritance where we acquire some properties of parent to child actually. So here, let's see an example of has a relationship where I have an engine class. Uh, so here in this engine class, I have a method. I have something called horsepower, and then I have a method which is called start. So here what I am doing is I am creating one more class, which is car class. Inside this car class, I have to have an engine. So what I am doing is here I am creating inside my instance method. What I am doing is I am creating an object for I'm creating an object for engine actually, so that uh, inside car I has it has engine. So car has engine. This is composition. Uh, what I mean, someone has also asked the same question in chat. I read the chat. They're asking, can we just give me a moment? They ask, can we transpose 15 variables from one class to other class? Yeah, in some sense, has a relationship does that. Let's say here in engine class, let's say if I have 15 number of variables or something like that. Now, as car is having engine, I can get all the methods or I can get all the variables as I'm creating an instance of engine class in my car class. I can do that in underscore underscore init method here. So yeah, the thing is that whenever you are creating an instance, you have to pass all the variables that it is requesting for. So here, this is has a relationship. This is an example of classic example of has a relationship where what we are generally doing here is that we are creating a car, and then we are also car is having engine. Car has a relationship with engine. So here if I have a start underscore car method, what here I am doing is I'm just calling start method, because if I start engine method, my car will start, right? So self dot engine dot start will go to engine method, and then it will call the start method actually. Yeah, and then if I want to talk about inheritance, as I said, it is getting some or acquiring some properties from parent to child actually. So here in vehicle class, I have move method, and then I have in constructor I'm defining a brand. I mean, I'm defining just defining the brand. So here, to do easy relationship, what we are doing is we are passing the child class as a parameter to this class, and then whatever happens, you'll get. I mean, the we'll get an inheritance or easy relationship by passing the child class to the parent class. I mean, we'll get that whenever we pass whenever we pass parent class to the child class actually. So here in the child class, we can access the methods, we can access the constructors of the parent class. That is what inheritance is all about. See here, if I want to access move method, I can directly access move method with the child class object because I can access as I'm inheriting properties from parent, I can get that. And then there are types of inheritances. There are single inheritance where we have one-to-one relationship. I'll close this topic in 5 minutes. Just let me share my screen. I don't know why my iPad is very slow today. It is taking so much of time for screen mirroring. Yeah. So in is a relationship we have different types. First one is single inheritance. So a single inheritance is nothing but if we have one parent and one child. This is called a single inheritance where this child will get all the properties of parent. Second one is multi-level inheritance where your child, you have a parent, and then you have grandparent. So yeah, there are three levels actually. This is your child, this is you, and then you have your parent. So this is multi-level inheritance, and then in addition to this, we have multiple inheritance. So single inheritance, as I said, we just have child and parent. In multi-level inheritance, we have child, parent, and then grandparent. Whatever the assets, whatever the methods, whatever the variables that are present in grandparent, you'll get that in parent, and then whatever the things that you are having in parent, you'll get that in child actually. And then there is something called multiple inheritance. Multiple inheritance is not possible in other programming languages like uh, Java, but multiple inheritance is possible in Python actually. How do we do that is we have something called MRO that is used for resolving the issue actually. So if you want to know more about that, as I said, I'll share uh, MRO technique actually, method resolution order technique, where it helps us to resolve this actually. So what exactly multiple inheritance is? Let's say if I have parent one, and let's say if I have parent two, and then I have child, and then the child is extending both the parent one and parent two, where let's assume that parent one has M1 method and parent two has M2 method. The child can get both M1 and M2 method. But let's say if parent one and parent two has same method, now let's say if the child want to access M1 method, what is the M1 method that we will get? That is an ambiguity, right? So that is the reason why most of the programming languages doesn't support that. But this MRO, the method resolution order, will help us to resolve that. So Python supports multiple inheritance. And then we have something called hierarchical inheritance. What is hierarchical inheritance? Hierarchical inheritance is an inheritance where we have two childs for one parent. Uh, so let's say if I have M method which can be accessed by both child one and child two. And there is one more inheritance which is called hybrid inheritance. What is hybrid inheritance is C1, C2, P, and then we have a grandchild. So what is this? You have two children with one parent. This is called hierarchical inheritance. And then let's say if I take this, what you have, we are having two children, and then grandchildren is getting both the properties from both the childs. This is called multiple inheritance. So if you combine if you combine any of two inheritance, then we call it as hybrid inheritance. Here I'm combining hierarchical inheritance with the multiple inheritance. That is the reason why it is called hybrid inheritance. Does hybrid inheritance possible in Java? Sorry, does possible in Python? Yes. How is it possible is, let's say if there is any conflict, let's say if M1 and M1 is methods that are present in both C1 and C2, then Python internally uses MRO and then it resolves that issue actually. So yeah, see here I am having parent and then I'm having child class. In parent class, I'm having show method. And then I am just printing that, and then in child class, I'm just extending parent class, and then I'm displaying. I'm using one more method which is called display, and that's it. I mean, if I call child method child dot show, I'll get the parent method because child is not having show method. But if I access display method, I'll get the display from the child class actually. Can parent get child methods? No, child can't get parent methods, but sorry, child can get parent methods, but parent cannot get child methods actually. That is the same rule that happens in real world, right? You'll get we as childs to our parents, you'll get the assets from them, and then you'll not get assets from our children. Yeah, so let's say this is multiple inheritance. I am having parent one and parent two. In parent one, I'm having show method, and then in parent two, I'm having show two method. So here, child is extending both parent one and parent two, and then let's say if child want to access show one, I'll get show one. If child want to access show two, I'll get show two, and then object dot display. As I said, let's say if parent one and parent two is having same method, which is show one and show two, that is resolved by using MRO, which is method resolution technique, which is from left to right. It follows, it creates a graph-like structure, and then it resolves that by using that structure actually. And then there is multi-level inheritance where you have grandparent, parent, and then child, or parent, child, and grandchild. So where whatever the properties that the grandparent is having, that you'll get it for parent, and then whatever the things that are available in parent, you'll get it to child. Actually, this is multi-level inheritance, and then we have something called hierarchical inheritance, where you have one parent and then you have two children. See here, child one is extending parent, and then child two is also extending parent. We are inheriting properties from parent to both the childs. This is called Mm, inheritance, I mean, hierarchical inheritance. And as I said, we also have uh, hybrid inheritance where what I'm doing is here child one is extending parent and then child two is extending a parent, but now grandchild is extending child one and child two. This is what the multiple inheritance, the diagram that I showed you guys. as I said, we will not get any conflict until unless if you are not having same methods. If you have same methods, the similar MRO technique applies here. And then what is the purpose of super keyword? The self keyword is used to access the current object values, and then super keyword, let's say if I want to access, see here, you have two methods. One method is show method, and second one is uh, the child is also having show method. What happens here is a method overriding happens. Method overriding is, let's say if parent is having same method and then child is having same method, whatever the parent method is, that will be overridden with the child method. I'll talk about that in a while, but let's say in child method, if I want to access the parent class methods, I can access that by using super keyword actually, and then I can also access parent level variables. Let's say if I'm having same variables in both the classes, I can access the parent class variables with super keyword actually. And what is polymorphism? As inheritance talks about acquiring the properties from uh, parent class to the child class. Uh, Parent class to the child class. Mm, what polymorphism does is that, let's say if we are having same functionality, so let's say here, let's talk about mm, I mean, you are the person in real world. You are involved in many other stuffs, right? You are the person, you are the teacher, you are the parent to your children, you are the son to your parents, you are boss in your uh, college. So what we are doing is we are performing multiple roles. Similarly, uh, what happens is you can have same method name, but let's say if you want to perform different operations, that is what uh, a polymorphism is. And the polymorphism is built on a philosophy which is called duck typing philosophy. Yeah, in polymorphism, the core concept is if one thing which performs multiple way, then uh, it is called polymorphism. If you perform single action in different forms, then it is called, as I said, it is called polymorphism. Uh, but method overloading is not possible in Python. See here, let's say I have a test class and then I have show method. So in this, I have for one method, I'm just passing nothing. This is no parameter method, and then here I'm passing one parameter. So if I access show off a parameter, this method will be overridden with first method. So I'll get this. I can run this if I do this. But if I call my first function, I'll get error actually. I'll get an error saying that one parameter is missing. So method overloading is not possible in Python. If you want to do method overloading, how can we do that is, as I said in yesterday's class, we can use positional arguments where, see, let's say if my method is having two parameters, I can store the two parameters in my args. Args is list here. It can store any number of parameters. It can store 5 comma 10 in args, and then 5 comma 10 comma 20 comma 30, and then you can perform whatever action you want. You can, if you want, you can print. You can, if you want, you can perform all the operation. But this is how we achieve a method of overloading in Python. But conventionally, you can't write uh, the same definition thrice and thrice and then pass different parameters. Instead, you have to use args, or you can use one more concept called default arguments. Arguments is also not that efficient. Uh, let's say if you want to implement method overloading, this is how you can implement that. Similarly, if method overloading is not possible, obviously constructor overloading also, I mean, it is not possible, right? So you'll get an error. Let's say if you access the default constructor here, the parameter is a constructor is I mean, here we are overloading here the thing whatever uh, the first method is it overrides the second constructor, the special method second constructor. So if I call first method, I'll definitely get an error saying that I want an argument. And then let's say if you want to implement constructor overloading, how can I do that? Is I can check the length of arcs. If the length of arcs is 0, I will have I'll do some. Go ahead. Okay. Okay. If no questions, yeah, we can. You can do something. You can say constructor with no parameters. If arguments is 1, you can say these are the arguments that are available, and then you can assign that to. You can assign that to yeah, local object or the current object with self keyword. You can do that actually. So this is how we achieve constructor overloading in Python. And then method overriding, we don't have any problem. See here, let's say if I'm having parent class and show method, and then child class show method. Let's say if I call child class show method, this block will be executed because whatever the parent class is, that will be overridden with the child class method. And then
Yeah,
similarly,
Shekhar, one quick thing. Let's say, how do I restrict the overriding? Let's say I have a method in a parent class. I don't want that to be overridden in the child class. How do I keep it? Or how do I keep a class from getting inherited?
so I mean, so you are saying that you don't want to override the parent class methods, right?
Yeah, there are two things. One is like I write a class A and I write a class B which extends A, but I don't want all the methods in class A to be overridden in B.
Mm-hmm, mm-hmm, mm-hmm.
And the second one is if I write a class A, it should not be inheritable. That should be the final class. Like I don't want that to be inherited anymore.
So you can okay. So in in our first case, so if you don't want to inherit a specific I mean specific methods, I mean if you don't want to do that, what we can do is I think we can call uh, specifically we can call with super keyword. That is what one thing that we can do. I need to check the other way actually. If you don't want to modify the original functionality, I need to check that. And then the second question, I didn't get your second question. So you are saying that you don't want to I mean you don't want to extend. I mean just like final keyword, right? In Java we
Yeah,
have
that's
something
right.
called
That's right.
final keyword.
Exactly.
I mean in Python, I think we also have something. I think if you have private keyword for class, one thing is we can't. I mean, we can't do extending. I don't think we have any other keyword just like final in Python. Mm, just give me a moment. Let me check. What?
I just googled the same question. It looks like Python doesn't have any feature that you can restrict any method being inherited to the child
Mm-hmm, mm-hmm.
before it
Okay.
gets.
Okay.
Okay.
Yeah. Thanks.
Okay. And we can also similarly, as I said, we can do constructor overloading, uh, just like method overloading. Yeah, this is polymorphism. Inheritance is just getting properties from parent class to the child class. And then overriding, polymorphism talks about implementing same functionality in different way, but overloading doesn't support in Python, but somehow we can do constructor overloading and as a constructor overriding and method overriding. We can also do overloading, but in not the same sense that we do in other programming languages. We can also do abstraction, and abstraction is nothing but, let's say, if you don't want to what is abstract method? There is something called, there are two types of methods. One is concrete methods, and second one is abstract methods. Concrete methods are the methods that you do implementation in Go. So here in mm, in let's say in child method, what you are doing is you are implementing the concrete methods actually. So a class is a pure concrete. You only have concrete methods in class, where you can only declare concrete methods in a simple class. So if you don't want to implement the implementation of that function, then what do is you take in help of abstract methods. What abstract methods is, you can if you don't want to do implementation and then if you still want to declare a method, what do is you generally declare that method as an abstract method. So such methods are called abstract methods. In Python, abstract methods are uh, declared with @abstract method decorator. Uh, and you can simply, in the implementation part, in this method implementation part, what do you write is you'll simply write pass actually. And then all the abstract method related information is present in ABC pack. There is one module which is ABC module. So let's say if you are doing abstraction, what do is, let's say if you're implementing uh, abstract classes, what do is you implement that, sorry, you import that module. So from ABC, we import ABC, uh, and then when, let's say, if I want to declare an abstract class, you'll definitely inherit that ABC class actually. And then you can have any number of abstract methods, and then you can have any number of concrete methods. So an abstract class can contain both abstract methods and concrete methods. And then every abstract class can be all the abstract class related information can be derived from that ABC class actually. That is the reason why we are extending that ABC class, and then uh, and that is as I said, as ABC class is present in ABC module, that is the reason why we are importing that actually. See here, and then for this is an implementing class. What implementing class does is that the implementing class should need to implement the abstract methods that are present in the abstract class actually. So yeah, so here in the vehicle class, what I am doing is I am implementing start engine method, and then I'm doing all the operations actually. So can we create an object for abstract class? No object class. Can we create an object for abstract classes? No, we can't create the object for abstract classes. Abstract classes can't be instantiated. And then, uh, yeah, let's say if vehicle, if the car class is also having some abstract methods, can we do that? Can we instant that? No, we can't create objects for the car class. Let's say if car class has some abstract methods. There is one more concept called interfaces, where interfaces are fully abstract methods. So class has fully concrete methods. abstract classes has both abstract methods and concrete methods, whereas interfaces it it only has abstract methods actually. Mm, yeah, if you want to implement the interfaces also, you can use the same ABC class. You can as most of abstract classes and interfaces are derived from ABC, so you have to import ABC and then you have to pass ABC interface. I mean, you have to pass that ABC class to your implementing class actually, and then so as I said, whenever we are talking about encapsulation, data security, we need to ensure that data security is also maintained. So to do that, we have three access specifiers. One is public, second one is private, and third one is protected. Public talks about if a variable or a method or a class, if it is declared as public, it can be accessed entire. Let's say if you are creating two or three packages, you can import that package and then you can access that class, or you can access that variable, or you can access that from anywhere actually. And then let's say if it is declared as protected, protector suggests that you can access that in the present class, and then it can only access in the child classes actually. If it is extending that, then only we can access the uh, protected variables or protected methods. Every protected method in Python are declared by underscore. Let's say if you are declaring a protected variable, you can declare that by underscore name. If you are declaring any method also, you can just have something called underscore as a prefix actually. And then let's say if you want to declare private variable, you can declare that with underscore actually. You'll have underscore as suffix, and then private is a variable which can be accessed within the function, and then you can't access that outside of the function actually. So I have a very small example. This can't cover all the scenarios, but say if you are declaring a variable inside a function, sorry, inside a class, this private variable can only be accessed within this class. Let's say if you have declare a variable as protected, and then let's say if you have 10 classes, and then let's say three classes are extending this parent class, then only you'll get this account type, and then owner is public variable. You can access this variable within all the classes within the package and outside of the package. So yeah, with that being said, we'll close our session here as it is 12. We can close this session here, and then we can continue our topics, the advanced topics like iterators, generators, and decorators in tomorrow's class. Not in tomorrow. I mean, we can start that in Monday actually. So this is whoops. I mean, this is more than enough actually. But let's say if you want to dig dive, you can take a look onto that from some of the websites where I'll post after this class in Classroom. You can look onto that. So yeah, that's it, guys. If you have any questions, you can ask me, or else you can.
Can you explain